All right, so we got this ballistic pendulum problem, bullets being fired into this hanging block. I'm going to say that the bullet is M1. This diagram here uses little m, big M. I don't like little m, big M because I get the m's confused. But I'll just tell you, the College Board, and we'll talk about this before the AP test, the College Board does do big M, little m. So you got to really exaggerate it, you know. Big M, little m, so you don't get them confused. So we'll say bullet is M1, block is M2. Now, we have the mass of the bullet, we got the mass of the block, and then we got this vertical height that the block rises after the collision, which we want to put into meters. So 3 centimeters is 0.03 meters. Then these masses, you want these in kilograms. That's 0.02. And then 700 grams is 0.7. All right, guys, right off the bat, what do we notice we have in this problem here? The bullet collides with the block. Whenever you see a collision, what is conserved? Momentum. So step 1 here, we're going to analyze the collision, the actual collision. So in a collision, momentum's conserved. So that's going to be M1 V1 initial plus M2 V2 initial, right? Because what's the equation for momentum? mv. Okay? Now in this collision, the bullet and the block stick together, right? The bullet gets stuck inside the block. So what do they share in common? What do they share in common? The same final velocity. So you could put the final momentum like this. M1 plus M2 V final. Now, in the homework set, the ballistic pendulum problem that you're going to see, the bullet does not get stuck in the block. The bullet goes through the block. So then what would this equation look like if the bullet goes through? The right side of the equation, you'd keep the momentum separate. M1 V1 final plus M2 V2 final. That's if they do not become stuck, right? But for this problem, the bullet does stay in the block after the collision. Now, what's the initial velocity of the block? The starting velocity of the block before the collision, 0. So that goes to 0. So we're left with M1 V1 initial is equal to M1 plus M2 V final. So we're looking for the initial velocity of the bullet, which is V1 initial. We're trying to get this guy right here. So V1 initial is going to equal M1 plus M2 V final over M1. So now, what do we have to find? To find out the velocity of the bullet before the collision, we need to figure out what is the final velocity after the collision. So the second thing we're going to do is we're going to analyze post-collision, after the collision. And by after the collision, I mean a split second afterwards, 0.00001 seconds after. The bullet goes into the block, bam, collision is done. What type of energy will the bullet block combo have immediately after the collision? Kinetic, and then that kinetic energy is going to get converted. So what happens to the bullet block combo? It swings up a vertical height. So this should sound familiar from last chapter. What type of energy did the bullet block combo gain? Potential. Assuming no friction, what will be true of those two energies? They're equal. So after the collision, we're going to say the kinetic equals the potential. The kinetic energy right after the collision is equal to the potential energy when the block swings up, right? Okay, so kinetic energy is 1/2 mv squared. This is mgh. Just realize these masses here, those are the combined masses. You want to add the masses together, but it's not going to matter here because why? they cancel. Mass cancels out. So velocity is going to be square root 2gh. So you plug in 2 times 9.8 meter per second squared. H is 0.03. And we get a velocity immediately after the collision of, hold on, I wrote it down, 0.7668. And don't round this because you're going to plug it in. Don't round this number. All right, so what velocity is that? It's that velocity right there. It's V final post-collision. Okay, so the total combined mass is 0.72. The velocity post-collision is 0.766. I'm out of room. 0.7668. And then the mass of the bullet is 0.02 kilograms. So we get a final velocity, the initial velocity of the bullet comes out as 27.6 meter per second. Right? V1 initial comes out as 27.6. So any questions on that? Now look, what is the most common mistake that students make on a problem like this? And dude, every year I make a big deal and I tell students, like, don't do this. You can't do this. What do I see on the midterm? Students doing what I'm about to tell you not to do. The mistake that kids make on the midterm when I'm actually grading your work, it's a written exam, kids will say this. They're like, okay, the bullet here starts with kinetic energy. And then what do they set that kinetic energy equal to? The kinetic energy after the collision. Can you say that the kinetic energy of the bullet before the collision is equal to the kinetic energy immediately after the collision? Because a tremendous amount of energy is lost. Where is that energy lost to? Friction. Like when the bullet goes into the block, dude, when the bullet goes into the block, that's big friction as it shoves its way in there. The bullet hole is going to be super hot. You lose, more than 90% of the kinetic energy, okay? But what's the amazing thing? Even though energy is lost, momentum is not. Momentum is conserved. Okay, so let's do the next two. So finding kinetic energy lost, you have to be able to do this. The kinetic energy lost in the collision. Dudes and dudettes, if you lose something, I don't care if it's money or friends or your self-respect, hopefully it's not that. Whatever you lose, whatever it is that you lose, if you want to know how much of it you lost, like actually put a number to it, you got to know two things. What are the two things you have to know to find out how much of anything you lose? How much you had and how much you ended with, right? How much did you start with? How much did you end with? So let's apply this to kinetic energy. If we want to find out how much kinetic energy is lost in this collision, we need to figure out, well, how much kinetic energy is there before the collision, and then we got to find out how much kinetic energy there is after the collision. All right, what's the only thing with kinetic energy before the collision? The only thing that has kinetic energy before the collision is what? The bullet. That's the only thing. So you go 1/2 mv squared. The kinetic energy equation is 1/2 mv squared. You apply that to the bullet. You get 7.62 joules. So I'll show you how I got that. That's 1/2. Mass of the bullet is 0.02. Velocity of the bullet before the collision, we now know it, 27.6. And you know what? Make sure that's not rounded. I forget what it was. Let's see. Just don't use rounded numbers here. So that comes out as 7.62. Now, after the collision, what has kinetic energy? The bullet block combo. The bullet is inside the block, so that comes out to be 0.2117 joules. How did I get that? 1/2 0.72 kilograms. Hey, where did I get 0.72? You got to add the masses and put them in kilograms. 0.72. Velocity after the collision, we found it out already. It is 0.7668. We calculated that already. And then that comes out to be 0.2117. Okay, so we have our starting kinetic, we have our ending kinetic. How much kinetic energy was lost? Subtract them. We lost 7.4. Now, final thing. What's the percent loss? That's one that's always a stumper. Finding the percent loss of kinetic energy. All right, you ready? I'm going to make this easy. You wake up one morning, you have $100 in your pocket. Somewhere along the way, you lose 10 bucks. I don't know. It just falls out of your pocket. There's a hole in your pocket. You lose $10. If you have 100 bucks and you lose 10, what's your percent loss? 10%. Well, think about how you did that. Things are always easy with money. You think about money, everybody understands money. They're like, oh, that's easy, 10%. As soon as we start talking kinetic energy, it's like, what? Percent loss kinetic energy? Well, look, what would be an equation for percent loss? Percent loss. So you wake up with 100 bucks, you lose 10. That's a 10% loss. How'd you do that? How much you take what you lost and divide by whatever you started with, the initial. Lost over initial times 100 is percent loss. How much did you lose? Divide by what you started with. So let's apply that to this problem. How much kinetic energy did we lose? About 7.4. How much did we start with? About 7.6. Times that by 100, it's about 97%. 97% of the initial kinetic energy was lost.